Okay, let's look at some polar equations. What is that now? So we've got a rectangular equation, 4x plus 7y minus 2 equals 0. We want to write it as a polar equation. So for all of these, we're going to be using the SOHCAHTOA definitions, the Pythagorean theorem, and possibly some of the identities along with the basic algebra. So x is r cosine, y is r sine. So you just make a substitution for x and y right there. Factor out the r, divide by the portion in the parentheses, and you end up with what I got circled right there. When you are writing them as a polar equation, you should go the extra step to solve for r. So you always want to end up with an r equals. Okay, example 2. X squared plus y squared minus 2y equals 0. So again, just substitute x squared plus y squared, Pythagorean theorem, r squared, y, r sine. Because we've got the squared r and the r term, we can factor it out, and then each factor becomes a possible solution. Now, r equals 0 as a polar graph is a single point at the origin, whereas r equals 2 sine theta is going to give us an actual graph with loops and swirls and whatever like that. So if you do factor like I've done here, the r equals 0 is not by itself a solution. The r equals some equation is going to have r equals 0 as part of it. So there you go, just be aware of that. So back on this first line, you don't want to go r squared equals 2r sine theta and then stop. That would not be a correct way to do that. All right, the next few examples are starting with polar and writing as rectangular. Now these are equations, they're not necessarily functions. So once you have made the correct substitutions, you basically stop and don't solve for y, don't solve for x, because that is just meaningless. Okay, so r equals 4 cosine, and we need to have a situation where we can substitute things. Now, is there an alternative way of doing this? Yes. And you could probably think of it if you want to. My solution was I need an r squared. Just like the previous example, I can substitute the Pythagorean theorem. And I need an r cosine, so I can make that substitution. So my solution was to multiply everything by r. Gets me r squared on the left. That gets me the 4r cosine on the right. And then I can make the substitutions right there, and I'm done. Alrighty, the next example. R squared sine 2 theta. Now sine 2 theta is an identity on the formula sheet. So there may be some of those things. So r squared, x squared plus y squared, sine 2 theta, 2 sine theta, cosine theta. And then I make my SOHCAHTOA substitutions right there. The 2 r's in the denominator multiply to be r squared. And then I can replace that with the x squared plus y squared. And that is where you can stop as far as I'm concerned. You might go the next step by multiplying the left side by the denominator, and you get that, quantity squared. But this is definitely one you don't want to go x equals or y equals. Next example. So this is similar to the first one that we did, just kind of going backwards with it. So anytime you do have that fractional or rational expression where you've got a denominator, you multiply, to the other side with the denominator, and you can see. And then the SOHCAHTOA substitutions for r cosine, r sine, x and y right there. Now this equation is just a line, so it is a function. And if you do have instructions that say and then solve for y or something like that. You do need to follow those, but typically the rectangular equation, you just stop. One caution about this is you never want to use the inverse function to cancel the trig part. That's not a valid technique. Our final example, r equals 2 cosecant. Use the reciprocal identity. Again, denominator, multiply to the left. Substitute with the SOHCAHTOA, y equals 2. And those are the parametric equations. There's a polar equations. I'll get it right here. There are a huge number of variations with all the trig functions. I mean, this last one, there's 6 of them that I could do, and depending on which trig function is more complicated, the same thing for this example. 3 that I've got here, there could be different trig functions here. There could be different things squared. There could be different identities, either with the basic identities, the reciprocal Pythagorean quotient, the identity sheet. There's so many variations. I could just do examples for hours, and it still wouldn't cover everything. You've got to practice as much of these as you can. There's some on WebAssign. There's a bunch in the lab manual. There's other videos, other notes. There's the textbook. So practice as much as you can, and I'll stop talking.